and you are suffering the effects of Bidenomics. Let me introduce you.
Okay, so in the last video, we kind of breached the subject of, danger, safety, leakage from the line, possible electrocution, or at least a good tickle from some of these AC-DC receivers. And the S-120, of course, is the culmination of a long line of Hallicrafters receivers from the 40s and 50s, and it's a third generation AC-DC set that was submitted, we found out, to Underwriters Laboratory, tested in the lab, and deemed safe enough to get the Underwriters Lab seal of approval. So I'll be changing out the caps in here, putting in some safety caps, putting on a polarized cord, all the proscribed things, short of an isolation transformer. Well, I've actually got another isolation transformer suggestion, and I've been playing with this receiver now for a couple weeks, and I've had several of these S-120s come through. It's interesting. The S-120, being an off-the-line set, seems to be very subject to picking up noise from the line, and it gets into the receiver. You don't see that with transformer equipment as much. A lot of that noise doesn't go through a transformer, but it sure is getting into this set. And of course with AM radio, maybe we see that at the lower part of the band with all that buzzing you hear now. That never used to be there, by the way, guys. And some of these sets probably will never perform as well as they did in the day because there's so much noise from light dimmers, solar, from pool heaters, from HDTV, video systems, everything from your fan on down is on that line now. And it seems to be getting into some of these AC-DC receivers. In the comments, tell me if you've been noticing anything like that. So beyond the safety discussion for an isolation transformer, we have to start thinking about noise and noise injection into the receiver. Hope you enjoyed the second video on the S-120. I have another couple of videos on the S-120 on the internet that take you a little deeper into the alignment process. So if you're interested in that aspect, we certainly will be aligning the receiver, but there's a lot more detail in some of those other videos, and I'll leave the links for you guys. In releasing the outer case from the chassis, it looks like the feet are on with screws. Okay, I'm pulling it out of the chassis, and I can tell right off the bat the speaker looks great. There's a good possibility this radio's never been opened before. I don't know, I see some capacitors here that look newer. Maybe this thing has been recapped. We shall see. It's fairly apparent that some work has been done to this radio. Looks like the three main electrolytic capacitors have been changed, as well as the bypass capacitor on the cathode of the 50C5 output stage. The selenium rectifier has been switched out to a silicon diode. However, I will investigate this and see if possibly a late model S-120 would have received a diode like this, because it looks like pretty good soldering work here, so I'll look at that a little closer. I think because the caps have been changed out here, I will do a ripple test to see if there's any hum from these capacitors. You can kind of tell where they've been working because there's some little black dots on the chassis where there's been little pieces of rosin or something that's gone down and blemished the chassis. Whereas over here, where nothing's been done, it's pretty clean. But interesting, this radio has had some work. So another point that's very interesting in this radio, remember I told you that the outer cover of the radio was somewhat insulated from the chassis, and this was measurable, actually, electrically. You can see the amount of work that has gone into isolating the outer case from the chassis using these inserts, which are insulated. And, more importantly, look at this cork insulator between the front panel and the chassis. to include a fiber washer on the headphone jack. So they're going way out of their way to try to separate the chassis from the outer case by using all of these insulating points. So there's a little bit of extra safety built into the radio compared to a normal metallic Hallicrafters radio that has a transformer. Of course, the transformer gives intrinsic isolation, but here they're getting the isolation by using insulation methods. So that's probably how they were able to get the thing through UL testing. Now, of course, as time goes on, this cork insulator could get water, it could break down, and slowly the resistance starts to go down and your isolation goes away. But they really went out of their way to try to get some form of insulation in this radio. I'm pretty impressed. Before I attempt to do any testing on this radio, I will use an isolation transformer system. It's just two 5-amp transformers back to back. So you get 120 on one side and 120 on the other side. And then the ground is brought through to the case on this outlet. And I have a circuit breaker there. It's a 3-amp circuit breaker. Now, once we've isolated the radio, we can plug it in. And of course, the whole thing is floating now. You do have to establish a ground if you want to use it with a test instrument. And the last thing you want to do is have the test instrument supply the ground. So the first thing I'm doing is I'm attaching a ground wire securely to the chassis to the ground point on the outlet. Now I know that the radio is truly grounded and that the AC is referenced to something. It doesn't matter how I plug this in. There is no hot and neutral here. This is isolated AC. Doesn't matter which way I plug it in. So this is the safe way to start taking measurements on this radio. Now if we want to hook up an instrument like an oscilloscope so we can measure the ripple on the power supply in the S-120, now that we have established ground and we have an isolated situation with AC, we can hook up the ground from the oscilloscope or the meter or whatever we're using directly to the chassis. And now we know we have a good reference and we can make measurements with no trouble. Now you want to put the lead from the oscilloscope in the 10x position so you can get good measurements. So I had one commenter that said that I really am not able to make proper measurements of isolation in a radio like this using a modern meter because its impedance is too high. So I have dug out the beast. Yes, look at this thing. Ooh, the Simpson. We might have to make some measurements with the Simpson just to see what we're doing here. Okay, so I'm looking at the ripple at the first capacitor. This is the one that basically is coming off the resistor after the rectifier, going into the first cap on the S-120. And I'm reading 5 or 6 volts peak to peak. And this is the 0.5 volt scale, and we have a 10x probe. So that comes out to a couple volts RMS at the first capacitor. I don't think that's a problem. I think that's normal ripple on that first cap. And if we go to the second cap, let's see where we are. Notice the ripple's already pretty far down. So I'm going to say that this recap that was done on this radio, oh yeah, that's the third cap, is rather new. These capacitors are fine. They do not need to be changed. So if there is any hum in this radio, it's not due to these capacitors in the power supply. So looking at the schematic, here's the capacitor that's between chassis and ground. And here's the capacitor that's between line and ground. So the one that's between line and ground, we're not as concerned about that as far as safety is concerned, because if that shorts out, it's going to pop a fuse somewhere, hopefully. And it's not on all the time. If the switch is open, this capacitor is not under stress. Now, if you compare that to this capacitor, which as long as the line is connected, you potentially have hot in the wrong spot, and this will always have AC. And this could present a problem. The current going through this capacitor, of course, is what we're feeling in that tickle, should the line be swapped. And if this should short, it could be a safety concern. So this is the one that we want to use the Y2 capacitor on, because this is the one that if it fails, we want it to fail open. Fail open. Y2 capacitors fail open. So let's identify where they are in the circuit. This is the guy that is the one we want to fail open. Over here we have the line, and over here chassis, and over here we have the line. This one comes back and connects to here. This is line. And the other capacitor is over here, kind of hiding. This is a 0.022 600 volt. So I'm going to put the Y2 capacitor here. Now, what value should it be? They put in a 0.047 capacitor at 600 volts. And I'm going to be replacing that with a Y2 capacitor that's probably a 0.01 at 250 volts. Now, the 0.01 at 250 volts being a Y2 capacitor is far safer than a 0.047 at 600 volts. It's safer for two reasons. It's safer because it's rated for surge voltages. It's rated for surge voltages, and it will open when we have a problem. It's also safer because this is 0.047, and I feel that that value is very high and will put more current through your body. So I'm going to make it either a 0.0047, like a 4700 puff, or a 0.01 to take the place of this. So I've worked a little bit on the tuning controls and the lubrication of the dial. I put some dry lubricant on the spindles that drive the dial silk, and we don't have any more sproink, sproink, sproink here. This is all tuning nice and smooth on the band spread. Given the bushings, the deoxit treatment, the bearings have got their grease. I worked on the bushings on these knobs to try to get some oil into them so it tunes a little smoother. Still tuning a little bit harsher than I'd like on the main tuning. It's nice and smooth now, but I think the dial string might just be a little bit too tight. But you know what? I'm not going to touch that because I don't want to make the dial string too loose. But yeah, this whole thing is tuning a lot smoother now. So the caps have been changed out. I tried to do as neat a job as possible. Any of the poor soldering that I encountered, I tried to reflow and clean using both solder wick or my monster solder sucker. And if I had to do a butt splice at all, I covered it with heat shrink, so it's not too bad. Now, there's one more thing that needs to be considered, and that is the polarized plug. The existing cord is about 4 feet long, and it's the old-fashioned cord, so I would like to put a polarized plug in here. One thing I found in doing a couple of these before was that the wire running all the way up to the on-off volume control, this guy is a hum producing situation. So if you can reroute that further toward the 50C5 audio output part. So when we had this cord, and of course everybody knows that when you plug in one of these and you get hum, try reversing it, and sometimes the hum gets less with these AC/DCs. Basically what you're doing is you're taking the chassis from being the hot to being the ground, and that calms the receiver down. That's an old trick. Now once we go to the polarized plug, we're supposedly going to guarantee that the chassis side is always the cold side, and that the hot side is going to go up here to the switch. Okay. The problem with that is that means that the 60 hertz AC is coming right up this way, and it's going to go right by the audio amplifier input over here, and worse than that, it's going up right to the potentiometer, which is the input to the audio amplifier. So I don't like these switches that have the AC right on the on volume type switches, but that's the way it is. Okay. My message is routing this wire from the new cord. If you can route that wire down this way and maybe sneak it over to the switch in a way that it's not coming in contact with the sensitive input circuit on this tube or up here, you're going to lower the hum. Okay, and I'm going to try to do that when I do the next when I do the new cord. Now I do want to go back and take some measurements with the old cord, because we want to see if we've done anything good or made any difference at all in the leakage that we measured. But then we'll take it out of the case again, and we will replace the cord with the polarized cord. And only then will I start the alignment procedure, which is next. By the way, there was something interesting I found over here by the trimmers. If I can zoom in a little bit. So all of these trimmers are grounded by being soldered right to this central piece, which is grounded to the chassis in the middle. I beefed that up by putting some ground over here, because I wanted to make sure I had a good connection to ground. These are the oscillators. I noticed that all of these terminals, which are normally grounded here, were just kind of laying against the chassis, and I thought that that possibly could make a diode and cause some issues. So you either want to solder those to the chassis, which I don't suggest doing, or just lift them away from the chassis if they're touching. You don't want dissimilar metals touching each other if they're not soldered. They'll form a diode. So anytime you see something like that, where something's just laying against something, that's a chance for trouble. That's why they took all the time to make sure that this stuff was well grounded here. Same problem. And around the tube sockets too. This rivet right here on the 12BA6 IF amplifier is completely loose, and they're depending on that as a ground. You never want to depend on the center of the tube socket as a ground. So I'm going to solder this good and bring it over to this well-known ground over here on this terminal strip. So anytime you can beef up these rivet grounds and get a better ground to chassis, this is the time to do it when you're doing the improvements and the replacements on the receiver. Also, loosening and tightening each one of these ground points. Anything that's a screw, put a little bit of deoxit in there and loosen and tighten those. That's going to, again, improve the grounding situation. It'll make alignment a lot better. I did not use all of the capacitors, since two of them at least were replaced by the X2 and the Y2 capacitors, so I had a couple left over. And I did not use the electrolytic for a couple of reasons. First of all, the electrolytic that's mounted in the radio looks really good. I mean, cosmetically it looks good. It's on top, so you want to leave that. And these capacitors that were down in the bottom here are new electrolytics, so why would I want to mess with that? And we have very low ripple on the power supply. I would say leave it alone. But you'll notice over here we have the capacitors that were removed. And of course, Murphy's Law says these capacitors are absolutely fine and that it was a complete waste of time to replace them. Okay, that's possible, right? Let's prove that by using our fancy capacitance tester. And this capacitance tester will be able to check the capacitors for leakage and high pot them and see if their values have changed and so on. So we will see if it was worth replacing those capacitors. Okay, we are on the line again. I'll turn this down. Let's see what we... Looks like we have a 0.5 volt to my ground over here. So the plug happens to be in the right way over here. I don't know if you can see that, but the plug is plugged in, and it's plugged in the right way because we have very little voltage between the chassis and a real ground. So let's turn this off. Let's switch the plug around. Let's turn it back on. And now let's measure to chassis. And we have, the full 120 volts to the chassis just like we did last time. But this time we're going to try to use the Simpson VTVM or a VOM and try to get a little better. So we now have the magnificent Simpson 312 vacuum tube voltmeter. The problem with the Simpson, this Simpson, is its input impedance is probably a little over 1 megohm. So it's not as high as the solid state voltmeter, which has probably many megohms of input impedance, but it's still a very, very good meter, and its input impedance is probably over a meg. So let's see how many volts we've got. Remember, last time we were measuring the full 120 volts on the high impedance meter. Let's see how this one does. Well, it's about 85 volts. 85 volts RMS right here. Okay? 85 volts RMS where we measured the full line voltage on the solid state meter. So, yeah, if we were to use a real Simpson VOM with, just a few thousand ohms of input impedance, it would be even lower. And of course, this is just a simple voltage divider problem. So, just wanted to show you what it would look like on a different kind of meter. And now the Simpson with the plug reversed, hopefully in the proper way, and it just barely moves off the pin.
I'm still here. Yeah. Well, good on the Nano device there. Sounds like you're gonna have some fun with that. And sounds like you've got some. Morning, Ben. Morning. Is that the one you could hold it up and put at the show?
But they made a bunch of different 50s. They even have what they call a Q50, which was just a little tiny thing.
So this is 40 meters, early morning.
Roger. Okay. Glad everything is okay. I got food in a rough couple of weeks. It seems to all have passed. Lay down.
So we didn't actually get to align it or put it in the case, but the next video will take care of that. I think we have done a pretty good job looking at the components and the change outs we've done. And let me tell you, those rivets, they've really got to be taken care of in this receiver. They were all loose. Several of the grounds just were not stable. So you've got a little bit of soldering to do to get some of those rivets around those tube sockets in good condition.